Swayam Prabha. Digital India. Educated India.
For the 1st of February and the 2nd of February. Okay, 1st of February and 2nd of February. And so this is for you to get familiarized with the software. One of my students will be taking the workshop, and after you get familiarized, the next AutoCAD session will have you work on a little problem. Okay? So that would be on the 8th of February and the 9th of February. So this is the tentative schedule. Badges B4, B5, B6, B1, B2 and B3. They will be doing their labs as well as workshops on Friday in between 9 and 1. Be polite. And the rest of the 6 badges, they will be working on Saturday. So I believe you're going to be having your NCC or NSS or whatever, CPA on Saturday mornings. Yeah? Okay, so I'm assuming that you are free in the afternoons of Saturday. Okay, so it's from 1:30 p.m. 1:30 p.m. till 5:15 p.m. So if you scroll up a little bit on my web page, we have a manual for you. We have a primer. Okay, so you can download it, take a printout, make copies, borrow, steal if you want to. Okay. I believe that in the labs we also have internet connection, so if you don't want to take a printout of this, you can access it through the net, but whatever. I would suggest that you take a printout of this and have a copy of this with you while you're working with the problems in AutoCAD. So today we'll see another example in orthographic views, third angle. And this is this is the solution to one of your problems in lab 3. Okay, things will get a little complicated from now on. So some of you are not able to access the PowerPoint presentations through the web. Is it the case? So I believe in Computer Center you'll have either the Linux based labs or the Windows based labs. So I have a feeling that you would be able to access them through the Windows lands. Okay, so try that out. Linux, I'm not really sure if they would support PPSX. Okay, let's get started. You know, when I was on the other side of the table, when I was sitting amongst one of you long time ago, not so long ago, we used to see this ad. Do you know who this is? Okay, one more time. Okay. Set of curves, set of lines, ellipses. Gels very well with what we are discussing in class. And there was a statement with this ad: the greatness of this man was his simplicity. Okay, he taught us, he taught the entire world a lot of things. And I would want to say a lot of things about him, but I would rather focus on the example But one of the things that he taught about, or he taught to us, was to go bottom up in anything that you're doing. Don't go top down, but go bottom up. That is the logical way of approaching any problem. Okay? And TA is all about going bottom up. All right, so example 2. This is going to be a little complex. So we are going to be drawing the orthographic views, third angle of this solid. Okay? So this happens to be one of the problems in lab 3. Okay? So I'll project this picture for a while. You have your notebooks and pens in front of you. How about taking 5 minutes and trying to sketch this without making much noise? Five minutes is too less a time for your sketch, but try it out. So let me hear only the scratch of your pen on your notebook, nothing else. Think and analyze. So of course, this side of the solid is the front view. So for those who have already done lab 2 yesterday and today, is it a little more difficult or quite straightforward? So we have two cylindrical features here. Okay, so if you're having a hard time understanding or imagining the solid, I would suggest that you break the solid down into different features. So you would have two cylindrical features here, one rib at the back, one tapered rib on the left, okay, two supporting ribs behind, okay, a plane with a, so to speak, elliptical void, and these are circular through holes. Okay? So break the solid down into different parts. That will help you imagine the solid a little better. Okay? Let's start drawing. Focus on the bottom right box of your sheet. Fill out the details. Yeah? Can I go back a little? These? Yeah. 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 Well, the pictorial view of this is not so very clear, but your assumption is valid. So you have to assume that they go all the way back. They stay horizontal and they go all the way back. Okay. So first fill out the details in the bottom right box of your sheet. Use the convention for third angle projection. Okay. So for this one, I'm using scale 1:1.5. Okay. I'm using scale 1:1.5. All right. What's the first thing that we need to do? Huh? Hinge lines. But before that, identify 3 critical dimensions. Identify 3 critical dimensions. So if you assume this plane to be the reference plane, okay, this dimension over here corresponds to the dimension here, okay, the height of the rib. This one here takes you back from the reference plane, and this would correspond to the length of the cylindrical features. All right? Okay? So this drawing, we'll draw this using reference plane in mind. Okay, let's see how. Reference plane, draw the hinge line that differentiates between the front view and the top view. And then what? Okay, bounding box. What is the length of this? 60? What are these bounding boxes corresponding to? The cylindrical features. Okay, that's what you would see. So you would see this plane, and then you would see these cylindrical features. So it's actually 60, but the scale is 1:1.5. So I'm reducing the dimensions. I'm reducing all dimensions by 2/3 or 2/3. Okay. I'm making a mistake. Good. So long as you are realizing, or so long as you realize that you have to show 2 dimensions, I'm happy. For now, I'm showing the scale dimensions for you to understand. Okay. What is this height? 90 times 203. Take the projections up. The first thing that you would want to draw in the top view is the reference plane. This plane. Okay. So you would see that this plane is a line, or is represented by a line in the top view. Okay. What is this dimension? What would this dimension correspond to? How much? One of you raise your hand and 24 scaled dimension. Scale dimension 2/3, na? Okay. So from this reference plane, you are now measuring the feature at the back. Okay, what is this dimension? Okay, I'm depicting the scale dimensions. So this is for you to realize the scaling. All right, so the top view will be bounded within this box. Okay. Take this projection upwards. Okay, and draw the bounding box for the cylindrical feature. What is this dimension? Good. Do the same for the other cylindrical feature as well. So of course, a cylinder is symmetric about its axis. You show the axis AXES of the 2 cylinders using dash, long dash, short dash, long dash, short dash. Okay, or dash dot, the convention that we have been using. And then start relating the top view to the side view using projections. 45-degree line. Okay, go down. Relate the side view to the front view as well. That's your reference plane in the side view. What would this projection correspond to? What would this projection correspond to? The cylindrical feature in the side view. So this is the box that bounds the cylindrical feature here. Okay, it's symmetric about its axis. Show the axis of the feature. So once you have the groundwork done, okay, once you have the groundwork done, start drawing solid lines. Start with the base. Okay, first step. Then what? The vertical on the left, vertical on the right. So this line corresponds to what? Yeah? No? This one projected on the vertical plane. Good. This edge corresponds to what? This one? Good. That's the rib projected on the vertical plane. Okay. What's the width of this? Right? Okay. Let's proceed. This is the circular void through the cylindrical feature. Okay. The center is the intersection of two dashed dotted lines. Right? Same thing on the right. Would you see this edge? Okay. Should I be drawing the full circle or should I be drawing 3/4 circle for this? 3/4? Okay. How about the circle on the right? 3/4? Now be a little careful here. Be a little careful here. What do I do next? I need to worry about this dimension, huh? Okay. This dimension is 8. I draw a little fillet from both circles and I join the two fillets by a straight line. Okay. Okay, am I done? Still a long way to go? Okay, okay. All right. Settle down. What's next? Dimension the inner void. What's this called? What's this called? Phi. All right. Phi what? What is this part of the dimensioning called? Leader. Angled at 45 degrees to the horizontal and then followed by a horizontal line. This is R12. What is this height? See this gray line here? What is this height? I am drawing this void now. Settle down, settle down. What is this height? Okay. Look at the first center. Locate the second center. What is this? Huh? Okay. What is this distance? I'm helping you with one of the solutions. Okay, come on. What is this distance? Huh? 14 point? Okay. How I located the two centers properly? One here, one here? Yes or no? Okay. Draw two semicircles. Join them by two straight lines, and you have what? You have a void which looks almost like an ellipse, but it's not an ellipse. Okay? It's a slot. Am I done? What am I left with? One at a time. Somebody raise your hand. Yeah. The dashed lines of the backward, these guys? How about this guy? Still a long way to go? We'll come back to the front view a little later. Let's start with the top view. Two cylinders. Okay. Now, hold on. The extreme edges are long. The intermediate edges are short. These two edges are long. These two edges are short. Why is that? Why is that? Because of this feature, no? Right? So it becomes easier for you to have a reference line or reference plane and then draw things with respect to that plane. Okay. Take the projection of these circular voids upwards to the top view and use dashed lines to show this void in the top view, and likewise for the void on the right. Okay? So this is an example that will demonstrate that it is there are chances that you're going to be missing out quite a few lines. Not just one, not just two, but quite a few. Yeah? Well, what edge? This circle? This one? Will it be visible? We'll come to that. So for now, are you with me? Are you with me for now? Okay. Who's not with me? Okay. Huh? It'll be a curved part, all right, but imagine this to be a cylinder. Okay, what do you see? Rectangle. Okay, so imagine only this part. What do you see? A line? We'll come to that. We'll come to that. Yeah. No, but we'll come to that. We'll come to that. So if I'm making a mistake, feel free to correct me, but catch up with me. Okay? You're with me now? Good. Stay with me. All right. Would you see this line? Would you see this line? What would this edge correspond to? What would this edge correspond to? This guy here? Would you see this line? Yeah? No? This would correspond to this over here, I believe. Is it? Right? Okay. Now comes the important part. So this is a rib, okay? And the rib is such that a part of the rib is tangent to this circular feature, here and here. Okay? How would you show that? A line, okay? It's kind of extended up till the axes of the two cylindrical features, okay? And to show that it is tangent to both the features, we use a little convention. We show a little arc on both sides. Okay? Once again, this rib is tangent to both circular features. Okay? So correspondingly, the line is going to be extending towards or up till the axes of the two cylindrical features. And to depict or to emphasize that this rib is tangent, we use two circular arcs at the two ends. Okay, something new. Okay. What is this dimension? What is this dimension? What am I doing now? I'm taking the projections from here to represent this void in the top view. Okay? You'll see two hidden lines, of course. Where would they be? Where would they be? Where would they be? One would be here, and the other one would possibly be here. Once again, watch carefully. All right? Things are getting a little complex. Now I'm taking the projection from here for this rib. What would I see in the top view? A hidden line. Okay. Up to where? Up to where? Up till the reference plane, nah? Up till this plane. Okay? Up till this line here. Okay. Coming to the side view, cylindrical feature is easy. Cylindrical void is also easy. Yeah. Which one? Yeah? Yeah? This is like a tapered rib. Where are you? Yeah. So this is like a tapered rib. Okay. So it is glued to the reference plane. Okay. So here the thickness of this rib is 0, and here the thickness is 24. Is it scaled or unscaled? Unscaled. So 2/3 of that is 16. Okay. So if this is your reference plane, at the bottom the rib is going to start from here, and at the top it's going to come here. Okay. Right? And since the rib is hidden behind the circular feature or cylindrical feature in the top view, it will be shown using hidden lines. Yeah? Hold on. Are you all with me? Who's not with me? You're not with me. You have a doubt. Inclined. So this is an imagination issue. Okay? Folks, be polite. So you'll start imagining things better once we start dealing with isometric views. For now, assume that this is like a tapered rib. Okay? All right, so coming to the side view, cylindrical feature, cylindrical void. This is what? Reference plane. Okay? This edge. This is what? This edge. Okay? Straightforward. Steps, 2 steps, straightforward. This dimension, what is that? Okay? Okay? Now, so how are we doing this? We are sketching the front view in part, we are sketching the top view in part, we are sketching the side view in part, we are going back to the front view. Okay? And we are relating different features in all 3 views through projection lines, horizontal, vertical, right? So corresponding to this step here, there would be dash line in dash view, fill in the blanks. One hidden line, the second hidden line, and the third hidden line. And the fourth hidden line, there's no point because that is occult or that is behind this solid line. One at a time. I'll come back to you.
Would the extended part of the back also behind that strip?
Would this part?
Be also behind that strip?
Which strip? I'm so very glad that you're discussing amongst yourselves. Can I have all ears, please? All ears here, please. All eyes here, please. Thank you. I'm so very glad that you are discussing this problem, if you are, with your neighbors, which is a very nice thing. Possibly this is not the right venue for that. Okay? Feel free to go back to your hostel rooms and discuss this as much as you want. One lesson in fact, two lessons, one lesson in communication skills 101. Rather two. Lesson number 1. If you want to be a good speaker, you have to learn to be a good listener. Okay? If you want to be a good speaker, you have to learn to be a good listener. Right? And if you want to be a good leader, you have to learn to be a good. Okay? Which one? This one? Behind what strip? This one? So as I said, this picture is a little ambiguous. So assuming that would go throughout, okay, we are working with these solutions. Assuming that, okay. You will learn later how isometric views can be ambiguous. This is an example. So are you with me now? 3 hidden lines. Listeners, what does this stand for? What does this stand for? Huh? Calm down, calm down. Yeah? Yeah? Up to this band. Huh? Well, so, in fact, this is what I explained to Shekhari, Ayush. I'm assuming that these steps are going throughout, okay, behind the solid. Okay, so they're not stopping anywhere. I'm assuming that. I don't have the information, but I'm assuming that. They might as well have stopped over here. They might have stopped over here. They may have stopped over here. Okay, but in any case, I wouldn't have known about that, because that corresponding feature is hidden behind the reference plane. Okay, so there's a little bit of ambiguity in the picture, but I'm assuming that they're going throughout. It won't? Well, the picture will be the same or similar. Yeah, so as I said, I have to give you additional information here, which I haven't, but I have to give you additional information. Okay? For example, a phrase like extended throughout. Okay? Are you all with me? Okay. So, going further. This projection line corresponds to, so this would actually help you depict this void in the side view. Hidden or solid lines? Should I be showing this axis? Okay. Hidden lines, hidden lines. I'm jumping. I did a bit of side view and then I'm going to the top view. and I'm drawing the back portion of this. Okay? Now, look at these lines. Look at these lines. I didn't start from here. I didn't start from here. Rather, I started from here. Okay? If I take a projection of this, that would match with this vertical line. Likewise, if I take a projection of this, that would match with this vertical line. Okay? That would be a solid rectangle. Am I done? Still some work left? What is your first impression about this drawing? Complex, simple, very simple? What? Complex? Difficult? Easy, very easy? Huh? Unclear. In the pictorial view, you mean? In the isometric view? The one on the right, top right. Yeah. So I agree with you. I agree with you. I should have given you more information. But it's only these parts in the picture which is not clear, or which are not clear. There are more? Okay. Which ones? Which ones? Which ones? These guys? These guys? These voids? Well, so hold on. So there is a term that we use to depict the depth of the void. Okay? Deep. So when I say phi, let's say 10, and then 10 deep, that means I'm referring to a pothole with diameter 10 and depth as 10 or 20. If I don't specify that depth, you assume that it's a through void. Okay. About 10 or so more minutes and then we are done. It's very likely that you're going to be missing this line in the side view. Okay, there's so many lines. Thank you. There's so many lines that you're drawing, that's very likely that you're going to be missing this line in the side view. Okay, that corresponds to this edge here. Okay, all the lines that I'm showing from now on are pretty much in red. These are the lines that you're going to be missing. Okay, top view, profile view. This is the line that you might be missing. Okay, what would this correspond to? What would this correspond to? Huh? This line corresponds to the intersection between the cylindrical feature and the rim. What would this line correspond to? This guy here. Okay? You might forget to represent this central, so to speak, elliptical void in the top view. Okay, so the center lines here, you've already represented this. What does this line correspond to on the right side? Right? What would this correspond to? It is this plane. It is this plane, right? In the RHS view. Are we done? No? So when you're drawing these orthographic views, you need to be very, very careful. Okay, and one way to practice or exercise care is to ensure that each and every feature in each and every drawing is related by the corresponding projection line or the construction line.
The arc is not needed in that side of
This arc? Huh? No, but this arc is okay. This arc is used conventionally to show tangency between two features. Okay? So it's just to show that this rib here is tangent to the two cylindrical features on the left and on the right. This one? This one? These guys? Huh? What do they correspond to? The two centers. Don't miss out any, hold on. So don't miss out any solid line, don't miss out any hidden line, don't miss out the center lines, don't miss out the lines of symmetry. Okay? Be very careful, yeah? You know, I believe in learning by making mistakes. Okay? And I'm not at all shy to admit that I make mistakes. I made a mistake. So notice that I'm using a different, can I? Notice that I'm using a different dimensioning scheme. I'm not using aligned dimensioning, but I'm using center line dimensioning. Differences are subtle. Differences are subtle. The number or the dimension is represented within the arrow. Okay, almost at the center of the arrow. Okay, and whether you're using horizontal arrows or vertical arrows, the numbers, they remain what? Aligned to the horizontal. They don't get rotated as it is in case of aligned dimensioning. Okay? Again, as I said, there are mistakes. One of the foremost, or one very glaring mistake, is the fact that I have used scale. I've used scale dimensions. I've not used true dimensions. So when you're making this drawing in your lab sessions, make sure that you don't make the same mistake as I did.